مساء الخير، اهلا بكم. انا دعاء حماد، ريسيرشر في قسم الانثروبولوجي المركز القومي للبحوث. هنتكلم النهارده على محاضره عن الابيليبسي. انا فكرت الابيليبسي هو بيتكلم عن ايه، فلقيت ان هو في جمله كده بتتقال: if the brain is a musical instrument, the electrophysiology is the music. With the technology we can now listen to the music a little bit better. هنحكي قصة توم كان عنده ابيليبسي من هو عنده 16 سنة. هنحكي قصته لحد ما بقى عنده 48 سنة. 16 years, his first big seizure came when he was 16. His mom heard him making strange sounds. She went upstairs to my bedroom and I was just in full convulsions, Tom says. My bed was completely soaked through with sweat and my head was contorted. Tom woke up in the hospital, but once doctors put him on an epilepsy drug, his seizures stopped. يبقى ده الفيرست لاين اوف تريتمنت لاي حد عنده epilepsy هو anti epileptic drugs. طبعا الانتي epileptic drugs ليها محاضرة لوحدها وليها حاجات كتير، بس دي يعني تجميع للانتي epileptic drugs. من 16 years old to 25 years old, Tom went to college, worked as an English teacher in Mexico, came back to California, and moved in with the woman he would later marry. By that time, Tom's doctor had cleared him to stop taking medication. They both hoped he had outgrown his epilepsy. طبعا ده كان أكبر غلط الدكتور طلبه منه. Then he had another big seizure and another trip to the hospital. Now you know, I am 25 and I am diagnosed with a potentially devastating, potentially uncontrollable disorder, Tom says. That meant some daily activities were no longer safe. Suddenly, you can't take a bath anymore, he says. You can't go swimming anymore. No more free weights in the gym. طبعا الحياة مع الإبليبسي حياة صعبة جدا، وده اللي هنشوفه مع توم في الحياة بتاعته دلوقتي. Tom tried to adapt. He found a job, got married and had kids, but his epilepsy began taking a big toll on his family. في 2009 when Tom's epileptic seizures could no longer be controlled with drugs, فهو اتشخص medication resistant epilepsy. He started considering surgery. دي بقى second line of treatment. He underwent a Grolin evaluation at the epilepsy center. Doctors removed a piece of his skull and placed electrodes on the surface of his brain. He spent a week in the hospital while doctors watched him having seizures. هي دي الطريقة اللي كانوا بيشخصوا بيها في الوقت ده. طب ايه types of epilepsy surgery اللي كان ممكن توم يعملها؟ corpus colostomy, hemispherectomy, deep brain stimulation, functional hemispherectomy, laser interstitial thermal therapy أو resective surgery. لكن للأسف then he got bad news. You are not an optimal surgery patient. He recalled the doctors telling him, we don't feel safe operating on you. Surgery is often not the only option. After being told he wasn't a good candidate for surgery in 2009, Tom had returned to work, still struggling with uncontrolled seizures. Within a couple of years, though, he lost his job, his marriage ended. في 2018, with epilepsy taking a heavy toll on his work and family life, Tom went back to his doctors to discuss treatment options. كان بقى في الوقت ده بدأت بقى التكنولوجي تطلع وبدأت بقى الدنيا تتطور. As a surgeon, you can't hit what you can't see. New forms of MRI help surgeons reach their target without damaging other brain areas. The doctors told him, you know what, we are in a unique situation now, where we have some of the newer technology that were not available in 2009. This time, the team inserted tiny electrodes into Tom's brain to find the primary source of his seizures. Then, in 2009, they used a laser to remove that bit of his brain. Listening to the music of the brain. The changes in epilepsy diagnosis and treatment rely on improvement in monitoring the brain's electrical activity or electrophysiology. If you think about the brain like a musical instrument, the electrophysiology is the music. For so long, we were only looking at a picture of the violin. Now, we are able to listen to the music a little bit better. That means doctors are more likely to detect a sour note, like the one produced when brain cells produce the faulty signals that can cause an epileptic seizure. Stereotactic electroencephalography is a minimally invasive neurosurgical method to localize epileptogenic brain regions in epilepsy, but requires days in the hospital with interventions to trigger several seizures. Surgeons drill one or more small holes in a patient's skull and insert electrodes into areas of the brain thought to be causing a patient's seizure. Then they wait until the patient has a seizure. For Tom, that meant many days in the hospital with wires coming out of several holes in his head, but it paid off. We were able to see that there was one specific region of his brain that was really the driver of most of his seizures, the doctor said. Tom also benefited from technology that allows SEEG information to be combined with high-resolution MRI scan. That shows surgeons precisely where the trouble spots are. In Tom's case, that laser energy was delivered through a probe so thin it could pass through a drinking straw. The probe, guided by an MRI scanner in the operating room, heated up the target area and actually knocked out that very active seizure fox. It was a single hole, a single stitch, and I don't have a scar, Tom says. That was all the more impressive given that the surgery to diagnose his condition in 2009 left a V-shaped, J-shaped scar running from his right ear to his forehead. هي دي السكار اللي كانت موجودة في العملية القديمة، لكن العملية الجديدة ما سابتش أي سكار خالص. هنتكلم بقى على حاجة جديدة اللي هي الروبوتس اند البرين ديفايبريليتورز. طبعا هي مش جديدة يعني في العالم، بس جديدة بالنسبة لمصر، لسه ما دخلتش مصر أصلا. يعني أنا سألت أصحابي اللي شغالين في النيورو سيرجري قالوا لي لا لسه ما بيشتغلوش بيها. الجهاز نفسه اسمه the ROSA brain robot act as a sort of GPS for the brain. It allows us to essentially steer a robot arm that takes us right to our target. The ROSA brain robot, which stands for Robotic Stereotactic Assistance, essentially act as a kind of GPS for the skull, guiding surgeons to precisely insert electrodes into the brain. These electrodes then provide critical information used to plan effective treatment and surgical interventions. The robot is a tool that allows us to identify the source of seizures with pinpoint accuracy. This is a dramatic departure from traditional procedure in which a craniotomy was performed. craniotomy دي اللي هي العملية اللي كان توم عملها في الأول اللي سابت له سكار كبيرة أوي. The device assists surgeons with a wide variety of medical indications and surgical interventions such as biopsy, electrode implantation, open skull surgical procedure that require a navigation device and other procedures. النافيجيشن ديفايس ده في مصر اسمه الملاح الجراحي. ده موجود في مصر بيستخدموه، اسمه الملاح الجراحي. The patient benefits are revolutionary: reduced morbidity, patient experience less pain, less risk of bleeding and infection, speedier recovery. Overall, this procedure is just tolerated much better by the patients. Patients don't have a big incision. For surgeons, providing 3D imaging of brain wave electrical activity allows surgeons to sample larger areas of the brain with minimal risk. We inserted 12 electrodes into the patient for seizure monitoring زي ما باين هنا في الصورة اهي. The patient tolerated it really well and basically took no pain medicine. We collected a lot of good data from the monitoring and now have a couple of surgical options that are being considered. Rather than doing a large cranial incision، ده كان السكار بتاعت الكرينيوتومي زمان، ده بعد 2 weeks وده بعد 2 months، وده السكار بتاعت يعني دي عيانة لسه عاملة عملية بالروبوت. ففي rather than doing a large cranial incision they would put in a multitude of electrodes through small incisions. This was a big chance. They went from making a large incision to making little tiny incisions. By guiding those electrodes into the precise location was challenging, enter ROSA brain robot. The robot automates most of that to keep you on the same trajectory, Dr. explained. This advanced technology opened the window for us to be able to more effectively treat many more patients with a fraction of the risk. It is truly groundbreaking. Rosa brain robot can also be used in a procedure known as responsive neurotransmission. Up to 2 electrodes are placed into brain using these robots that are essentially like a pacemaker in the brain to stimulate activity. الصورة دي من الويب سايت بتاع روزا نفسهم. Rosa One Brain robotic technology can assist in a variety of neurosurgical ranging from epilepsy surgery and functional neurosurgery to endoscopy. These include SEEG, deep brain stimulation, stereotactic biopsy, ventricular endoscopy, transnasal endoscopy. Created by device manufacturer Zamet Biomet, Rosa brain robots have been approved by the FDA, have been adopted by surgical teams worldwide. Rosa is being used in more than 150 hospitals worldwide, has been used to perform 9,000 procedures to date, according to the company website. هنشوف السلايد الجاية فيديو بيحكي عن جراح بيتكلم عن ازاي هو الروبوت ده يعني فرق في الجراحات قد ايه، وكمان هيحكي قصة مريض ازاي حياته اتحسنت مع الروبوت. والمريض ده برضو بيبين ازاي ان هم ركبوا تشيب في دماغه وعن طريق جهاز بيعرف يعمل ايه، يشيل نفسه من غير ما يروح المستشفى.
Very specific parts of the brain, and for that we use robotics. It's impossible otherwise. So what those electrodes are doing are measuring from not just the surface of the brain where they go in, but into the brain where we think seizures are coming from anyway. And what the robot does is allows us to place those electrodes into the brain with sub-millimeter accuracy. Because you can imagine, putting a stick into the brain, you have to avoid critical structures, you have to hit your target, and you have to avoid blood vessels. So that allows us to do sub-millimeter accuracy, so it's fantastic technology and essential for any surgical epilepsy center.
I had the 16 holes drilled in my head with his robot, as he calls it.
We performed that surgery at Cardinal Glennon Children's Hospital, despite him being an adult, because that's where the robot lives. So Brady Rising was worked up by our adult surgical epilepsy team. And in his case, we actually had a hypothesis that it might be either temporal lobe. So our plan was to insert electrodes left side, right side.
So it was trying to see if it was coming from the left side or the right side. Unfortunately, I had them from both sides.
So fortunately, not a candidate for a surgical resection. But what we did offer him was a very new technology called responsive neurostimulation. Our investigations did localize the seizures to the hippocampus on both sides of the brain, left and right. There were multiple surgical options. He decided on the one which I thought was the best, which was this responsive neurostimulation. And what that does is that has us insert those similar types of electrodes using the same robot right down the barrel of the hippocampus in both sides in an operation. We connect those electrodes to a computer and generator that actually replaces his skull and sits under the scalp.
Here's the device that's in my head now.
And what that computer does is it constantly reads electrical activity from those areas of the brain that are very, very active. If it senses a seizure, it can actually fire a signal and hopefully abort that seizure before it happens.
I just go on here and you hit step 2, interrogate, and then it identifies, and I stick it right on top, and it tells you the quality on the computer and the status of how fast it's going. It's gathering the information, and I just leave the wand on the same spot until that green line is all the way at the end.
The advantage of that technology as well is that over time you're gathering information over days to weeks to months. So eventually, after potentially 6 months to a year, we may be able to look at all the information we've gathered and say, hey, you know what? 95% of your seizures come from the left, with very few that start on the right. So if we offered then a temporal lobectomy on the left, if the seizures are still not controlled with this technology, then potentially we can do a better job at controlling the seizures overall. But I have inserted that type of technology in a girl with similar left and right temporal seizures, and she was so satisfied with it, she didn't need anything else.
I haven't had one other than forced ones from the hospital or from those big tests I've had. So they just gave me my license back finally. So
the biggest thing is an adjustment because he's so used to living the life of I don't know what's going to happen today. And he can actually take a deep breath now. that's what's been the biggest adjustment, is that he doesn't have to live in fear so much anymore.
It's very satisfying to actually rid someone of their seizures that they've had for usually years and years and years. And eventually, sometimes we can actually remove them off any of the medications that they're on. A perfect result is classified as an angle of 1, which means no more seizures. You can still be on medication, but there are some kids we can actually take them off medications and not even have the side effects of those medications. And for families, it's life-altering. That's what we've trained to do, and it's very, very rewarding.
Tom was happy to be part of that revolution. He still takes medication to remain seizure-free, but he is remarried, working part-time, and driving a car for the first time in years. I have a sense of independence now that I hadn't had since 2007, he says, all thanks to technology that didn't exist back then. Tom is 48 now. He is seizure-free as long as he takes his medication. There are a growing number of patients like Tom. Their stories show how new technology is changing the way doctors assess and treat drug-resistant epilepsy. Thank you, Purple Nation.